In this video, I will discuss the properties and uses of thermoplastic and thermosetting polymers. I will also relate the molecular structure and processes of each polymer to what happens on a macroscopic scale. Thermoplastics and thermosets are both materials that are classified as polymers. Polymers are very long molecules that are composed of smaller repeating units called monomers. In fact, the word polymer originates from the Greek words poly, meaning many, and meros, meaning part. There are many different structures of polymers, each being an indication of their macrophysical properties. Thermoplastics in particular usually have a linear or branched molecular bonding. This explains the distinctive response of thermoplastics to temperature changes, which will be discussed in the next slide. When thermoplastics are heated, they soften and eventually liquefy. Contrarily, they also reharden when cooled. On a molecular level, this is because an increased temperature causes increased molecular motion, which overcomes the secondary bonding that holds together the polymer chains. This process is both reversible and repeatable unless the thermoplastic is raised to so high of a temperature that the individual polymer chains begin to break apart. Although thermoplastics harden when cooled, they are still relatively soft when compared to thermosetting polymers. Before being heated, thermosetting polymers are composed of many individual polymer chains. In this form, thermosets are usually a liquid. Heating previously unset thermosetting polymers causes cross-linking to form between the polymer chains, forming a network molecular structure. Network molecular structures have extensive cross-linking between the polymer chains, unlike the linear or branched polymer chains in thermoplastic polymers. The extensive cross-linking of treated thermosets holds the polymer chains together very tightly to resist molecular motions. This causes thermosets to be much harder and stronger than thermoplastics. After formation, thermosets also do not soften up upon being heated, but will still degrade at very high temperatures. Now, I will discuss the uses of thermoplastics and thermosets. Since thermoplastics are ductile, easily formed, and relatively cheap, they are materials suitable for many applications. Some of the most common applications include toys, drinking bottles, and plastic grocery bags. Thermosets are also very useful for many applications. Here, I'll only list a couple of the most common ones. Because of their liquid to solid transition properties, thermosets can be used as adhesives and protective coatings, or because of their high heat resistance and low conductivity, they can also be used as insulators. However, keep in mind that even among the individual polymer categories of thermoplastics and thermosets, there can still be a significant difference between different types of thermosets or thermoplastics within each category.